It doesn't pick up that much. All right, so number 85, 85 through 88 are, oh, just kidding. You're right, 83. And so, we're still expanding logarithms in 83 and 84, so let's do those right quick. So I've got three different variables, m, h, and q, inside the logarithm, and they're all multiplied times each other. And logs combine with terms combined using multiplication can be separated using addition. So I'm going to say 4 log base 4 of m, so the first one, bring the power to the front, plus, because of multiplication. Now, the fourth root of h to the third is h to the 3 over 4, so we'll bring the power to the front. 3/4 log base 4 of h, and then plus again, and then this has a understood power of 1, so it's just going to be log base 4 of q. One thing you definitely need to be aware of is that your base needs to be lower, written in a subscript compared to your logarithm and what you're evaluating, so make sure it looks like that. Okay, so number 84. We've got three terms again, x, y, and z. We've got multiplication in the numerator, and then we're dividing, so we're going to have log base 4. We're actually going to have 3 logarithms. In the first one, you can switch these and put them in order if you want, but I'm just going to go ahead and do it as is. Y, it would be y squared, but when you're expanding, you should have no power, so power to the front. Times, so plus, power to the front, that's x with a 3 in the front, and then division can be separated using subtraction. And this is z to the 7th, and so 7 to the front, and there you go. On number 85, we're starting to solve exponential equations. So, do you have a calculator? You probably want one. So, on number 85, I'm going to approach these things in a couple different ways. I've got an exponential equal to a number. You could convert, or you could take the logarithm of both sides. It's kind of how you see it. First I'm going to convert, and then I'll show you the other way. So I could do log base. Okay, so the base of the exponent is the same thing as the base of the log. So log base 11 of 93.6, and then equals the power r plus 5. The goal is to solve for r, so final answer, r equals log base 11 of 93.6. That's inside the logarithm. We're taking the log of this number, and then minus 5 outside. Okay, so if I wanted to type it in, I could go alpha window number 5, log base 11, 93.6, and then minus 5. So if, as far as the decimal goes, negative 3.107. I would accept either answer, but if it's multiple choice and it's a decimal, then just match it to that. Okay, but like I said, you could just think about applying the opposite operation. So I'm just going to do that first step with you. So I'm going to leave a little bit of space between the equal sign and 93.6 and just talk about it. As far as solving this goes, the inverse of an exponential is a logarithm. So what you could do, instead of converting to a log, is just take log base 11 of both sides, because that's the inverse of 11 to some power. Those would cancel out, and you'd be left with r plus 5 equals log base 11 of 93.6, which is what we were solving right there. Okay? So just another way to think of it. And I will do that on this one. So on 86, we could convert. Log base 18 of 71 equals negative 3p. Or you can think of it like this. It's 18 to some power, so the inverse of the exponential 18, base 18, is log base 18. So it's like we're going to take log base 18 of both sides. So think of it like this. I've got negative 3p equals log base 18 of 71, because the log base 18 of 18 cancel each other out over there. Does that make sense? Okay. But like I said, remember you can always convert. I don't know if you can even read that. But make it a little bit clearer. Log base 18. So we're taking the log base 18 on both sides. Okay, and then I need to solve for the variable p, so I'm going to divide by -3. Just make sure that you're dividing the entire logarithm by -3, not just the 71. So you could say -1/3 if you would like to. Log base 18 of 71 is the answer. Oh, p. Or you could just write all divided by -3, but we are just going to type it in. I'll type it in how we saw it the first time. Alpha window, log base 18 of 71, and then all of it divided by -3. And you get -0.492 or 0.491 if you don't round. Oh, can you even see that? Okay. Sorry if you couldn't see that. Alright, so number 87. We've got 2e to the n minus 1 equals 38. So, in order to get the exponential, get rid of the exponential expression, or to get the n out of the exponent, I have to get everything away from the exponential expression. Right now it's e to the n minus 1 is being multiplied by 2, so I need to divide by 2. So I've got e to the n minus 1 equals 19. Okay. I'm going to write this out twice because I want to think about it two different ways. Kind of like how we just did a second ago. Okay. One way, like I said before, convert. So log base of the exponent is e, so log base e of 19 equals n minus 1, add 1, and you've got your answer. Log base e of 19 plus 1 equals n. And then write that as a decimal. The other option is, remember that the inverse of the base e is the log base e, but hopefully you remember that log base e is the same thing as natural log. So I could just take the natural log of both sides, and those would cancel each other out. N minus 1 equals the natural log of 19, which is the same thing as log base e of 19. So we're in the exact same spot that we were right there. Okay? I would leave it as ln. In fact, I would prefer ln because I want you to know that log base e is natural log, but it's not a requirement. I'm going to type it in to prove it, though. Not that you can see that. Okay, can you see both now? Okay. So, log base e. Log base e of 19 and then plus 1 versus natural log of 19 plus 1, and they are the same thing. Okay? So 3.944. Okay, number 88. We've got another e. So I'm going to subtract 4 over. E to the negative 8k equals 41. And the inverse of e is natural log. So I'm just going to take the natural log of both sides. So natural log of this, natural log of that. Let's cancel out. Negative 8k equals the natural log of 41, which means k equals the natural log of 41 divided by negative 8, so I'm going to float the negative to the top and divide it by 8. So you could leave it like that, or you could type in and get the decimal. Negative natural log of 41 divided by 8. Negative 0.464. Alright, so numbers 89 through 92 all kind of have a similar thing going on, and it has to do with powers. So if you have a power chart, that would be a good time to get it out so you can use it. So we have 3 to the negative 3p equals 9. And here's, I mean, absolutely, we could solve this the exact same way that we solved 85 and just convert it to a log and go from there. But I could also use this. 3 to the negative 3p is on this side. 9 is just 3 squared. So I could just think of it as 3 to the negative 3p equals 3 squared. The bases are already equivalent, so I'm really just solving the equation negative 3p equals 2, which means my answer is a negative 2/3 when I divide by negative 3. And there you go. Number 90, we have 243 and 81, so your goal is to find 243 and 81 on the same column. And again, with 3, we see that 243 is 3 to the 5th, and 81 is 3 to the 4th. So this is 3 to the 5th in the denominator, yeah? So when I bring it up, it's going to be 3 to the negative 5th. So we're going to write 3 to the negative 5 to the negative 2x. So that is representing this fraction 1 over 243 equals, and then 81 is 3 to the 4th, so 3 to the 4th to the negative x plus 2. So because I have the same base, those are already equivalent, I'm really just dealing with this equation. Negative 5 times negative 2x is 10x, and 4 times negative x plus 2 is negative 4x plus 8. So I'm going to combine like terms and solve. So I'm going to add 4x over and get 14x equals 8, divide by 14, and 8 14ths simplifies to 4/7. And there's my answer. Number 91. So in order to do number 91, you need to remember this. If I multiply two things like x squared times x cubed, that is x to the 5th power. You add the powers when you're multiplying something with the same base. So I've got 5 to the n minus 3 times 5 to the 3n. That's the same thing as saying 5 to the n minus 3 plus 3n. You just add the powers. And 5 to the 3 minus 3n. So now I've got 5 to something equals 5 to something else. The 5's are already equivalent, so I'm really just solving n minus 3 plus 3n equals 3 minus 3n. And then I just combine like terms and solve. N plus 3n is 4n, so I've got 4n minus 3 equals 3 minus 3n. I'm going to add the 3n over and get 7n. I'm going to add 3 over and get 6, so n is going to equal 6/7. You good with that? Okay. On 92. So same deal. I've got two bases with the, or two exponential expression with the same base, so I can just add the powers. 3 to the negative 2x plus 3x, which is really just 3 to the x, 1x, equals 3 to the, well, 243 is what? 3 to the 5th? So those are out, and the answer is 5. That's kind of nice. So, alright, that's it for exponential expressions, or equations. You've got the kind where you're going to have to convert to logarithms, or use logarithms to cancel out exponentials. And you got the kind where they have the same bases, and you can just rewrite them and solve using the properties. Alright, 93. 93 is a log equation, but it's kind of a silly, well, it's not a silly log equation, but it's just that you got one log equal to another log, and it's just kind of like this 5 to this equals 5 to that. The 5's don't matter. The logs don't matter. I mean, they do in the end because I got to check my answer to make sure it works for the equation, the original one, but as far as solving, I can just get rid of them. So I'm really just solving 4n plus 7 equals 4 minus 5n. I'm going to combine like terms and move the 5n to the right. So 9n equals, subtract the 7, negative 3. N equals a negative 1/3. Now I always did say that you need to check your answers on logarithms because the log of a negative number does not exist. So when I plug in a negative 1/3, I get negative 4/3 plus 7. That's a positive expression. And when I plug in negative 1/3 here, I get 4 plus 5/3, which is a positive expression. So that is my answer. On number 94, we do not have logs on both sides. We do, however, have two logarithms on this side, so I do need to combine them. They're two logs separated by subtraction, so I'm going to combine them using division. Log base 2 of x minus 2 over the numerator divided by 3 equals 2. So we could convert this to an exponential expression, or I could just think about what's the inverse of a logarithm, the exponential, and raise both sides as a power of 2. So I've got x minus 2 divided by 3 equals 2 squared, which is 4. I want to solve for x. Right now it's being divided by 3, so the whole expression is. So I'm going to multiply by 3. X minus 2 equals 12, and add 2 and get 14. Good. So when I plug in 14, I get 14 minus 2. That's log of a positive number, so we are good. Number 95 has 2 logs on this side and 1 log on that side, so if I can get these two to combine, then I can cancel out my logarithms. 2 logs separated by addition can be combined using multiplication, so log base 8 of x times the quantity x plus 4 equals log base 8 of 12. Well, I've got one log equal to another log, so I might as well just cancel out the logarithms. So I'm really just dealing with this. X squared plus 4x equals 12. This is a quadratic equation. So what you want to do is you want to get everything on the same side. X squared plus 4x minus 12. Same side as the quadratic, I mean. And then try and factor. Are there factors of negative 12 that add up to positive 4? And there are x plus 6 and x minus 2, which means my answers are potentially negative 6 and positive 2. Now, you always have to check your answer, so if I plug in negative 6 right here, I get log base 8 of a negative number, so that's out. If I plug in 2, I get 2 here, that's okay, and if I plug in 2 here, I get 6, that's okay, so 2 is my answer. Okay. Number 96. I have one logarithm on the left-hand side, and I've got some other stuff going on, so let's get the log by itself. So first I'm going to add 5. Log base 5 of 6x equals 3. The inverse of a logarithm is an exponential. The inverse of log base 5 is 5 to the, so we're going to raise both sides to the power of 5. Or just think of it as converting. 5 to the third equals 6x. 6x equals 5 to the third, which is 125. X equals 125 divided by 6. 125 divided by 6 times 6 is 125. Log base 5, 125 is 3. We're good. Could you see that? Okay. 97. I've got 2 natural logs separated by addition, so I'm going to combine them using multiplication. So natural log of 3 times 2x minus 5 equals 4. The inverse of a logarithm is exponential. The inverse of natural log, which is log base e, is e. So we're going to raise both sides to the power of e. So I've got 6x minus 15 equals e to the 4th. So what you want to do is add 15 and then divide by 6. And there's your answer. You could type that in and get the decimal, but you don't have to, because that is the most accurate answer. And that is the end of page 11.